some backtracking applications we are already discussed the NQN problems, subset of some graph coloring techniques. So these are all for backtracking methods. Okay, now we are in the next design analysis of algorithm dynamic programming concept. So we already know that backtracking means it's a DFA method. Okay, that is you have to solve one by one from top to bottom. Okay, once if you are reaching the depth DFS, depth first search, reached in that depth, again we have to visit what are the other node. Okay, not visited, unvisited nodes. So these nodes also we have to visit. Okay, that is after reaching in the depth, again we will go back and we will visit all the nodes. That is depth first search. Okay, so now for that depth first search we are applied in backtracking methods. We solved some of the applications in backtracking, NQN problems, 4x4 QN problems, 8x8 QN problems, okay, and graph coloring problems, then subset of sum. So the next one is dynamic programming. Okay, so what is that dynamic programming? Let's see that what is the difference between dynamic programming, backtracking, and greedy method. Okay, how the dynamic programming is working and what is the definition. Let's see one by one. Okay, so this is for yeah, now it's clear, I think. Yes. So what is that dynamic programming? So this is also one of the approach. It's like a divide and conquer method. In that first unit, we are discussing that divide and conquer methods, the merge sort, quick sort problems. Yes, what is that? That is the problems are divided into number of small subproblems. And these problems are solved independently. And finally, we have to merge the result of individual problem in a biggest solution to the big problem. So that is called divide and conquer method. Yes. So now let's see what is dynamic programming. It is similar to same, but when we are dividing the problems into number of subproblems, these subproblems results are stored in a table. The subproblem results are stored in a table. So once we are stored, again, if the same problem is repeated, whenever the same problem is repeated, so we no need to calculate again for the subproblems, because we already that solution is stored in that table. Yes, so we directly take the solution from that table. That is, when we are doing this one, so your computation power, memory usage, this will be reduced. So in logically, it says that is exponential time will be reduced instead of polynomial time. Okay. Exponential time will be reduced. So for that only we are moving for dynamic programming approach. Okay. So here the subproblems are not solved independently in dynamic divide and conquer method. Okay. So the result of the subproblems, small problems are remembered and used for similar or overlapping subproblems. So wherever we have the problems, when we are using the dynamic programming method, it can be divided into similar subproblems so that the results can be reused. Results may be reusing for computing the same problems if repeated. So this is the dynamic programming main concept. So these algorithms are mostly used for solving optimization problem. Okay, that means before solving in-hand subproblem, dynamic algorithm will try to examine the result of previously solved subproblems. Okay, so the output of each subproblems are combined and you have to, in order to achieve the which is the best solution. That is, we have to optimize, we have to conclude from solving in that subproblems. Okay. So how can we say the dynamic programming, dynamic approach? So we already, I said, no, the problem should be able to divide it into smaller overlapping subproblems. Okay. And optimal solution can be achieved. That is, each problems they are divided into separately. So the result of each problem, we have to find out which is the best optimal solution of smaller subproblems. And these dynamic algorithms approach are used for memorization. It means it reducing computing repeated subproblems. So the solution that occupying usage of memory will be reduced. So what is the drawback of this dynamic programming with other approach, that is greedy method? Okay. So here we will make one decision at a time. In greedy method, we will make one decision at a time. So if you want to move from here to your hometown to somewhere, okay, there are so many possible ways, but at the instant time, you have to decide. You are taking only one decision at a time. Okay, to overcome this problem, we are using dynamic programming. Here, we will make more than one decision at a time. Okay. Suppose when you are started your journey from your home to college, suppose if you are coming another, you choose you have multiple ways. The one way it may be some traffic or some problems, road construction problem like that. Okay, at instantly you may be choose for another solution, another way. Okay, to achieve the solution. So that is the best benefit of dynamic programming. And we have comparing the dynamic programming with other approaches, greedy algorithm, divide and conquer, and backtracking method. I said no, greedy algorithm, it provides only one solution at a time, and dynamic algorithms are providing more than one solution. That is motivated for an overall optimization of the problem. Okay, the greedy algorithms are local optimization is only addressed, but dynamic algorithm, it is motivated for overall optimization problem. And we have the another one approach we are studied in the first unit, divide and conquer algorithm. Yes. So here, what we are doing, divide and conquer, that is we are divided into small problems. Okay. And the solutions are combined to achieve an overall solution. But in dynamic programming, we have to use the output of smaller subproblems, and they are trying to optimize a bigger subproblems. And this dynamic algorithm, I said no memoization to remember the output of already solved subproblems. Already solved subproblems, we are, whenever the same problem is repeated, recursion, repeated. So memoization process will be occurred in dynamic algorithms. What are the examples or applications of dynamic programming? So we already know Fibonacci series, yes. Knapsack problem, Tower of Hanoi, shortest path algorithm, digital algorithm, all pair shortest path algorithm, White's version algorithm, project scheduling. These are all some of examples. So in our syllabus, we have some applications. They are given that so that the problems are we are going to solve one by one by using dynamic programming method. So it can be used with both top-down and bottom-up approach. What is that? We have to solve the problem from root to child. That is top to bottom, top down. Bottom up means you have to get the results from bottom, client, child. Okay, that results are again, it is used for a next level of childs. They are used that output of previous one, and they solved, and we are moving towards the root. That is bottom up approach. Okay. So in dynamic programming, we are mainly use an optimization techniques over the client recursion. That means whenever we use a recursion solution, recursive problems, Tower of Hanoi or Fibonacci series, okay. So whenever we see a recursive solution that has repeated calls for same input, repeated function for the same input. So that time we can optimize it using dynamic programs. So we already know how to use when we are have the problem in dynamic recursive solutions. So the idea is simply you have to store the result of sub problems in a table so that we do not have any recompute them when it needed. So this is the simple optimization reduces time complexities from exponential to polynomial form. Okay. I said no Fibonacci series number, finding the Fibonacci series, we can get the exponential time complexity when if it is optimized by storing the solution of sub problems. So automatically the time complexity will be a linear one. It will be reduced. Okay. And this dynamic programming algorithm design method, because we said that the problems are divided, each subproblem results are stored in a table. So how this algorithm it is designed means it can be used when a solution to a problem can be viewed as the result of sequence of decisions. Please don't annotate here. Your name is showing who is annotated. Okay, who is drawing lines, everything it shows here. So this dynamic program is applicable where it is applicable. It is used when subproblems are not independent. That means when subproblems share the sum of subproblems. So that times definitely we are using the dynamic programming algorithms. That is, it solves every sub of subproblems. Just only one time we are calculate the subproblem results only once and then save its answer in a table. So thereby avoiding the work of recomputing the answer every time the subproblems is encountered. Okay. So what is the definition? And what is the general method for dynamic programming model? So we already know it is a programming techniques. Okay, we previously the definitions and computing power, everything we are saying in a theoretical way, but that is implemented by using the programming technique in which solution is obtained from a sequence of decisions. So this sequence of decisions are F1, F2, F3 like that. That is Fn minus 1 or minus Rn. Okay. So this is the formula for general method, the fundamental dynamic programming model. This can be F of R, fundamental of dynamic programming model. F of R equal to maximum 0 to R. Here n Pn of R plus Fn minus 1 R minus Rn. Here n is 2, 3, 4 up to n numbers. And f of n is 0, then the output is 0, and f1 of r equal to p1 of r. That means f1 of r is, this equation provides a relation of evaluation of f2, f3 up to fn. So this is the recursive function in the process. So if it is repeated untimely leads to the value of fn minus 1. So finally we can get that process fn of r after completion of n steps. And this dynamic problem are divided number of stages, and these sub-problem stages of an optimal solution must be encountered, that is made at each stage. That means at each stage, it takes into accounts of effects, not only that previous, that is next stage, but also an entire subsequent stages. That is the result of one stage is used for another stage. Okay. So this dynamic programming provides a systematic procedures whereby starting the latest of subproblems, problems and working backwards, that is makes an optimal decision for each stage of problem. So this information is the last stage is information derived from the previous stage. So that is, it works both top-down approach and bottom-up approach. Okay. And when we are designing the program, dynamic programming, we have to consider 4 major things. Okay. So if you clearly understanding the dynamic programming concept, then you have to follow characterize the structure of optimal solution and recursively define the value of an optimal solution, compute the value of an optimal solution in bottom-up fashion, that is solve the optimal solution from bottom-up fashion, that is breadth to depth. So that time it construct an optimal solution from computed information. So these are the 4 things we have to consider when designing that dynamic programming techniques. So who is the author or developed the dynamic programming? Bellman. Okay, Bellman is the author. He is the author or technique of dynamic programming upon his principle known as principle of optimality. Because every problems it provides the optimal solution. So the optimal policy has the property whenever whatever the initial decisions are, the remaining decisions must constitute an optimal policy. This is regard to the state resulting from the. And last, what are the general characteristics of dynamic programming? So the problems are divided into number of sub-problems and each problems with a policy decision required. Okay, each stage, each sub-problem has a number of stages associated with it. And the current stage is an optimal policy for the remaining stages is independent of the policy adopted. The solution of procedure begins by finding the optimal policy for each state of the last state. Whenever a recursive relation is available, which identify the optimal policy for each stage, that means that is we are having the n number of stages, the remaining given the optimal policy for each stage up to n-1 stages remaining. And finally, where we are applying this dynamic programming approach, that is our syllabus, they are given optimal binary search tree, 0/1 knapsack problem, traveling salesman problem, reliability design. Okay, and some more additional applications are multi-stage graph, matrix chain multiplication. Okay, so in our syllabus we have optimal binary search tree, 0/1 knapsack problem, traveling salesman problem, and reliability design. Okay, these are that applications. So in next class, let's see one by one how that optimal binary search tree works depends on dynamic programming concept. Okay.